Hi, I'm Leyla Naz Candoğan and this is my Phys-212 project. In this project, my aim was to examine one of the fundamental principles of quantum mechanics, the Heisenberg uncertainty principle, from different perspectives. To do so, I chose 4 different approaches. And here they are. My first approach was using sound waves to calculate and measure uncertainty of time and frequency. To do so, I used an app called Hypix in my phone. As I speak, you can see the waveform of my sound, and I can capture this sound for a period of time. This is the captured sound, and I can access this data easily from my computer. Once I download the data by using the Python code I have written before, I can easily apply Fourier transform to the sound wave and get uncertainties of time and frequency. The code will also plot the sound wave in time and frequency domains. Here is another sound wave that I have recorded before. As we can see, while the uncertainty of time has decreased, uncertainty of frequency has increased. My second approach was using light waves to understand this principle better. To do so, I conducted a single-slit experiment. I have 4 slits, each with different widths. I stabilized my laser so that it will pass through the slits and get diffracted. Here I have a screen with an LDR circuit that is able to slide so that I can measure the intensity of light at different locations. Here, I will measure the intensity at each location so that I can understand the pattern better and identify the locations of the dark bands. My third approach was using wave packets to understand the relationship between uncertainty of position and momentum. Therefore, I wrote a code which can operate in 4 different modes. With the first mode, I am able to generate a wave with properties that I want. It will ask me how many harmonic I want to add, and I will enter each property one by one. Once I enter them, the code will generate the wave and plot it in position and momentum domains, and calculate uncertainty of position and momentum. In the second mode, the code will generate the wave with the number of harmonics that I want. This mode allows me to experiment with higher number of harmonics. There are 2 options. Either the harmonics can have constant amplitude or varying amplitudes. Let's choose the second one. Again, the code will plot the wave and calculate uncertainties. The third mode is about comparison of 2 waves. It will ask me to enter 2 different numbers, each corresponding to the number of harmonics in each wave. Let them be 20 and 2000. Once I enter them, the code will plot both waves so that I can get a visual representation. Also, it will calculate uncertainties. Finally, in the fourth mode, I will give a target uncertainty of position or momentum so that the code will keep adding harmonics until it reaches the target value. Let's choose the position one and give the value as 4. As we can see, it will plot the waves, calculate uncertainties, and give the number of harmonics that it needed to add. My final approach was literature review. I read several articles on the subject, and here are some of them. They all help me to understand the real importance of uncertainty principle and how it's much bigger than just uncertainty of position and momentum. Thanks for watching the video.